So no questions. Right. So if you do not have any questions here, only thing is just make sure that just go through the calculations and check what I have done is correct as well, especially for the kinetic energy part. And then how I wrote the potential energy, because those are the two things that is that's kind of important here when you solve problems in Lagrange equation. You just draw the diagram, identify the constraints, and write the kinetic and potential energy. Write the Lagrange. That's basically you are done after that, because everything else is like mathematics that you have to solve the problem using the same method again and again, right? So it just practice is what is important to solve these problems, right? So I hope that you have an idea why we need Lagrangian mechanics or Lagrange equations to solve problems, right? I mean, if there is no use of that, why would you learn it, right? Because you already have the Newton's equation, right? I mean, you don't need like something extra to solve the same problem if it doesn't make things easy. So this is, so I hope that you would realize that why the Lagrangian mechanics is important at this point, and keep that in mind. Let me go into uh, the next section, which is about solving, which is actually about coordinates, degrees of freedoms, and constraints, right? So what I am doing now is I am going to properly prove you that how this Lagrangian equation works. So what you have seen up now is I just throw quantity called Lagrangian and then have an equation and find the same answer, right? There is no base for this one. So we are going to look at the proof of Lagrangian equations. And before that, we need to know some of the definitions that we are going to use. Definitions and some of the wordings and things that we will be using. Right? So that's the idea. Right. And since we have spent an hour with this one, so let's talk a bit about something else. Right, I guess I need to give you a few notices. One thing is actually some of them are not actually notices. One thing is you can see this great conjunction of Jupiter and Saturn on the sky these days. I mean, not in these days, it will happen on 21st, but still in these few days also you can see the both planets are very close to each other in the western sky. Right? So the western sky means, I mean, if you have done some kind of astronomy, you probably know that all the planets normally follow the same path as the sun. Right? So if you need to locate it without anything, those planets just look at uh, the path of the sun at the daytime. By the way, don't look at the sun directly, but just look at the path of the sun. Once the sun goes down in the same direction, you will see these two planets around 6. I guess after 6:30 and 6:45, you should be able to see it until 7:45 and 8. And if you are very close to, if you have like, if you do not have any distractions like trees and anything, and the sky is very dark, you should be able to see it until it goes to the horizon. Because these two planets actually already up in the daytime, so they are going down towards the horizon by the time we see it. So around 6:45, it will be close to the western horizon, but it will be little up. You can see it easily. I have seen that those two planets in past 2 days. And just try to go out and have a look at this, because this will happen like, I guess, 400 years, every 400 years, not every 400 years. The last time it has happened, I guess, around 400 or 360 years ago, I can't remember. Right? So just in case if you are interested, this is something to look at as you are doing like lectures online throughout the day. Maybe this will relax your eyes for some time. And the next thing is, if somebody asks you how to look at this, and don't tell these normal people just look at like 30 degrees up in the sky, because the general public don't understand these things. I mean, even you understand. I mean, easy way to look at it, just look at the moon, right? Because after sunset, the moon will be in the same direction, right? Not the full moon. I guess this is just after new moon, right? So this should be like, you don't have the full moon, only you have this part of the moon. And very close to the moon, you will see two planets very close by, two bright objects, right? Those are the planets that you should look at, right? Because I used to get these telephone calls in the evening sometimes, few people how to look at that. And then, I mean, you can help to others if somebody needs to look at those planets. And the next thing is, so I got some interesting statistics in the Physics Today magazine, I guess, a few days ago. I would like to share that with you so that you will see this. Let me stop sharing. I mean, this is something important for you, for your future, right? Just to keep you ahead of time. So I'm going to share a small graph with you. I hope that all of you can see it. And this graph actually say that somebody who finished a special degree like you and then went on to do PhDs, right? And after that, because this is another question that I used to get we used to get frequently from students. So I thought that I should show this graph to you. And this came out from one of the latest surveys from American Physical Society, I guess APS, yes. So they have did a survey to check, I guess during 2017 and 2018. This is where I finished my PhD as well. And just to check what these students are doing after their PhDs, right? And you can see that it's interesting to see that this in the graph that only 19% is now in the physics, right? You can see this orange color. Actually, that only 19% are directly in physics or physics related jobs. And then you can see 8% in physics education. Let's say that's 30% then, right? And then 4% goes to non-physics education, and 15% is in engineering, and 4% is in computer hardware, and 20% is in computer software, which is interesting, and 10%, which is like a considerable amount, is in the field of data science. And then 7% is doing a business, and then there are certain amount of percentages in other non-STEM, which means STEM means science, technology, engineering, and management. So non-STEM means they are not related to any of these fields. And other STEM fields, there are 3%, and in the field of medicine is 1%. And you should notice a very interesting fact about this graph and about the subjects that you are doing that you should be proud of, right? Engineers would end up with a job in engineering field, with being an engineer, and doctors would end up with a doctor, right, in the field of medicine. But it's for your degree, it's not like something like that. You could go for any field as you like. You can see that even 1% is in the field of medicine as well, not actually not doctors, but in other like other fields of medicine, like medical research. I know that some of my friends who finished their PhDs are working in the research centers about the medicine, right? Especially in Texas, there are these big medical research institutes that they used to hire physics people who did physics. Because the one reason is that they have this analytical skill that they can look at all the aspects in all the subjects, right? So this is why it is important. And I know that as a professional astronomer, that most of my colleagues who did like physics and astronomy, so they build up these huge data science skills, and then they used to go to these jobs in the data science. And sometimes even for me, it is hard to find someone to some of my colleagues in the field of astronomy, because they have moved out and do these data science jobs. They are more paid than academic jobs, so that's the reason. And so these are just some information that I thought that I should be sharing with you as you are beginning your career, which will be important for you in future. So make sure that, I mean, everyone who do these things follow the same courses as you are doing right now, classical mechanics and methods, those kind of things. You can see that it is not directly visible that you are going to use it somewhere, but eventually you will end up using all these things. So that's how it works. So this is one of the questions actually students have when they are discouraged at the beginning uh, of their degree, especially in the field of physical science and when you are doing a physics special degree, because that they think it's, if you go for a field like engineering, it's very direct and visible that once you are done what you are going to do. And for the medicine, it's the same. And some of these other professional degrees, so it's very evident that where you are going, right? And the unfortunate thing is that you can't deviate from that field if it is very hard. But for you, it's not the case. You can go into any of these fields, right? So I know that students who did physics special degree and then went to do engineering PhDs or masters, and then go into engineering field as well. Because this basic knowledge that you are getting from this physics special degree, like mathematics, classical mechanics, and then like for the other subjects like quantum mechanics, those kind of stuff, they are very important in the fields of, in the research field for every subject. So that's why normally students are got get hired for these other fields. If you look at those, right? And if anybody needs to read more about this, what are the careers, I probably would send the link from the latest magazine of physics today that came out to me, I guess, a few days ago. Yes, this is the October version, but there is an online copy that I can give this document. I will post it somewhere so that you can go and look at the statistics, right? You need facts to get something proved, right? So that's just to break some time from the subject. So let me just go back and start. Remember that the last time I was mentioning that this one thing that I couldn't do last time is to teach you a bit about how to use Python and Jupyter Notebook, because I may be using this in the future for few of maybe one or two exercises. So I would like to give a brief introduction for the next probably 40 or 45, 40, let's say 40 minutes for you about how to use this. And so I have talked to each of you and I figured out that all of you have done some kind of programming, right? And even who have the students who haven't followed industrial mathematics or the computer science, they have done some kind of a bit of programming, which is just an introduction. But the good thing is to learn Python and Jupyter Notebook. You don't need like very very like thorough knowledge in programming. You just need very basics, and then you can just read through it and understand. Right? For some reason, this is not done in any of our courses. So let me just introduce this to you. And this is actually the idea is just to build you an extra skill so that you can use it in future. So let me just so by the way, you can actually, even it is not related to what we are what I am teaching about classical mechanics. If you have any questions in the about the things that what you can do after the degree or those kind of things, you can just ask anything about those things as well. It's okay. Right, so let me get this document about using Python and Jupyter Notebook to start. And by the way, actually there is another notice for you. That is what I heard in past few days is the third year. This is just some information ahead of time, and these things can be changed. And at the same time, I guess you can prepare if that happens. So what I heard from the faculty is that they are going to start the second semester of the first, second, and third years. Right. So when this starts, you will get some extra lectures. One thing will be if students get registered, I will be starting the astronomy course, which is actually part of one of your courses in second semester of the special degree. Remember that you have a course called astronomy and cosmology, which you will have to follow in your second semester. However, if the third year's lectures starts, this first 30 lectures of this course is actually the same 30 lectures that I will be doing for the third year astronomy course. So which means before you start the cosmology, you will have to finish the astronomy part. And so you will have extra 2 lectures for astronomy from January 18th if the third year second semester starts, right? So it is not yet confirmed, but you will be informed, right? So I just need to give you some information ahead of time. And plus the next thing is you have to do this microcontroller programming course as well, because that also conducts in parallel with third year general degree students. But this is something compulsory for special degree students as well. So because of that, just keep those 2 things in the mind. So that will come in the month or so, because it's today it's still 17, but just to give you some information. Right, so let me go back to this, let me share my screen. Right. So I would assume that you can see my screen right now, which bunch of folders. And this is a typical screen of the Jupyter Notebook. So what this means is that this is a platform that you can write codes if you need, and at the same time you can write notes interactively in the same like interface, and then you can save these all the codes and everything with an extension called PHY4024. We call this as a notebook, so that you can run it in any computer if you have Python and Jupyter Notebook installed, so that anybody else can run the same codes, and then you will see the results just below the code. And this is very, very useful. And at the same time, if you need to take notes, you can do the notes as well, as you saw that what I used to do in the last lecture. So that is, I just did that as an example for you. And so let me just switch off the video now and go for now to install. If you have a computer, and don't worry if you don't have a computer, because I'm not going to do anything like special until you come here. But if you don't have a, if you have a computer, you can try install something called Anaconda. So this is completely free. Let me just give you the website, and there are versions for Windows, Mac, and Linux as well. So it doesn't matter which platform you are using. And if you go to this particular website, they have this package called Anaconda, and inside the package you have everything, including Jupyter Notebook and some of the other packages they use for data analysis and data science tasks, which is actually nice to learn yourself. And for this particular uh, course, let me just pull out one of these introductory material. So the good thing is, once you install this Jupyter Notebook, and if you type Jupyter Notebook on your terminal, it will bring you this particular interface that you see right now on your screen. And this will have like folders, whatever when you write this command, you will be writing it on a terminal. So when you write it on a terminal, whatever the location that you are in the terminal, for example, let's say you are in My Documents folder and write a command called Jupyter Notebook, then it will bring up this particular interface for you, which contains all the files that you have in your in that particular folder. And after that, what you have to do is, if you need to work on this Jupyter Notebook, just go to this right hand side. There is an option called New, and then there are a lot of other options available, but you need to open new notebook. So this is called Python 3 here, because I have this Python third version installed in my computer. So it will, you will learn it when you are doing it yourself, right? So you just click on that particular icon, and it will bring up this particular interface that you can start writing anything, right? And here you can see that there are some options right here: cut, paste, copy, the usual things that you would have in any computer application. And inside this box, you can select whether you are going to write a code, and there are other options like you need to add headings, and if you need, there is an option called markdown. So this is what I have used last time to create the notes like this. Remember that this note. So I just wrote the note in the interface. So these are called markdowns. You just write it and then select the option called this option that you called as markdown, and then now, for example, let's say if you need to write a classical mechanics note, you just write it here. And then from here, you need to select whether you are going to run this as a Python code or just some text. So if you select markdown, it will be like standard text. that you are writing, and then you run it from this button, right? Then you have the output at the same place, which is nice, right? And at the same time, if you can double click in that particular cell and go back and do any edits as you like, right? And then another way of running this is in the keyboard. You just hit shift and enter. You can just run the code or the words that you have written. And this is actually can be used as a calculator as well whenever you need, because if you need, let's say, you need to multiply, you need to add two numbers, you just add 2 plus 5 and then hit shift enter. It will give you the output straight away, right? Now the students who did like MATLAB or Mathematica, you may probably have seen the same interface. I mean, something very similar to this. And so it will be easy for you as well. And for the computer science, within the computer science, you probably know that you have done some programming languages. This should be much easier than that. But having this knowledge will help you in future actually for different things. So that's why I thought that I should be teach something using this. And there is an introductory notebook that I have downloaded from this professor from his course. Let me use this one right here, Jupyter intro. Once you wrote everything, actually you can save it. And once it is saved, you will get a notebook with the extension of PHY4024, like that you see here. Or you can save these as HTML pages as well. You just need to go to file and then download as HTML. And you can see there are some other options as well, that you could download it as notebook and a latex file, which is like a way that how you write PDFs. Right now for the and let's look at this introductory I5Y notebook, which gives you more information about the usage of Jupyter Notebook. So this is a notebook or a file that is written, and the last one is Professor Hiko. So I guess he is from one of the universities, and I took this web page from his course content page. So this has basic summary. So this Jupyter Notebook provides you with some of the essentials that you will need to know about Python and Jupyter Notebook for the purpose of his course. So this will be similar to the course that we are following, so that you are following. So that's why I took that particular information from him. Right, so this has very basic information that what is Jupyter Notebook and what are the advantages of using that. You can use it in computer, even a tablet, even in a smartphone. And then the Jupyter Notebook itself is divided into cells. So this is actually the cell that we are using. Right here, it is actually one of those cells. And so I'm not going to like read through everything, because please go through this and read it yourself. And once you read it, you can understand most of the things. And the interesting thing is, I think I have posted this notebook in LMS. If not, I will do that today. Once you install Anaconda and Jupyter Notebook, and once you download this, you can just run these codes and check how it works, right? So this is like a real-time thing. Right, so the first thing is, so let me go through some of the features that you can use here. One is that you can comment anything that you write it in this way with the hash sign if it is a code. And once you run it, so let me show that by running this here. So 1 plus 1, 1. You get an output as 2, right? Now here you need to multiply two numbers. Then once you hit shift enter, you will get the answer, right? This is how you can check. Now, if you download the same Jupyter notebook, you would get the same interactive features, and you can run it yourself and see how it works, right? And one thing to note here is, now these are just small Python codes, and you can see that it's not that much hard to like learn yourself, right? So it's just multiplication, you just write it like this, not like C or Java, which you need these different structures and those kind of things. So this is like, because it is easy to use, it has become one of the popular programming languages among everyone. Right? Because of that, you have to learn it, so which will help you in future. Right. So once you write it now, if you need to take a square of some number, it's a bit different. You have to put two asterisks here. Now 3 to the power 2 is written in this way. So that's something specific in Python that you have to remember, which will give you an answer. And like in the other programming languages, you have this print command that you assign a value x equal 5 for some variable, and if you print x, then it will give you the number 5 printed on the screen. And then if you need to write an equation like y equal 3x squared minus 2x plus 7, and then you need to print y and this is like plugging different values for y in this equation to get the answers, right? And you can add the strings if you need, like this. So you just add first name plus last name, and then you will get the final output. You can just read that, see that in Python, it is just very easy to read the code and understand, because it's a very, very high level language, not like C or Java, right? I mean, that doesn't mean that they are not good language. They are actually really good language. That's why computer software engineers use those. But this one is like for general purpose, that if you go into like fields like data science and those kind of stuff, then you need this particular language. So, and then there is, you can see when you need to run some of the mathematical expressions, sometimes you need this special packages that is inbuilt in Python. For example, now when you need to write, when you need to find the square root of 2, you have to have to import some packages. You can see that this is not working, right? You get an error message. And in the same case here, I want to find sine phi, it's not working, right? Now when this happens, this is because I have not imported some of the libraries. As you know that at least you have learned C in your, a little bit of C in your, what do you call this, CCIT course, right? First, even in C languages, you have to import some packages like that in Python. For all these mathematical calculations and expressions, there is a very comprehensive and very strong package called NumPy. And you don't have to separately install anything. These, once you are done with Anaconda, all these things will be here. All you need to do is run this command first, which means you are importing this particular package, and then then you give a shorter name for that, import numpy as in, right? Once you run this and then go back and run these cells, then you will get the value for the square root, because then you need to use this shorter name np right here, and then dot whatever you need, whatever the mathematical expression that you need, you can type here square root of 2 np dot square root of 2, it will give you the answer, right? And in the same way, if you need to sin phi, you just write. So it says pi is not recognized. Right, for some reason it doesn't recognize the sin phi, so I will look that separately. I need to check why is that. That may be for a different reason. Here is an example that you have numpy package as np and dot. You need to find cosine of 0, and we all know the answer is 1, right? So you find the np dot, the cosine of 0, and we know the answer is 1. And then we write print this particular expression. So it will print the answer there. That's 1, right? So I just ran it. And then it just worked. Right? And it is also easy to find errors here. If something got wrong, you just need to go and look at, just search in the internet. I mean, the most of the things are internet about the Python, because that is very widely used by in each and every field, especially in like for the fields like astronomy and astrophysics. We just use it for everything. And if you write import numpy, now there is no module like this or no package like this. It should be numpy, and this is just a printing error. When you type it, then you will get module not found error, right? Then all you need to do is just search in the internet, and then internet will tell you just write num in terms of numpy, just replace it by y. So those are how you just correct errors very easily without anyone's help. And then this numpy package right here is what we will use most of the time in these courses. And it has this powerful ability to make arrays of numbers in one particular line. So this particular code right here tells that make an array of numbers from starting from 0 up to 10 with space of 0.1, right? So once you run this code, and I have given a name, he has given a name for this PTS, and then you run the code. So let me run it again. So you will get an array of numbers starting from 0 up to 9.9, and these are like space with 0.1, right? So this, you can see how powerful these codes are. You can just from one line do a lot of things. And probably who did this computer science and IM, they know probably a little bit better about other programming languages, and they probably can talk with me about this and comment on this, because I don't have much exposure to. I mean, what we are doing is we just use the languages for different purposes. So I am not very good at like teaching computer science to you, and so you can just follow these codes to learn this languages like Python. And right here you can see that again you use np.arrange, and then you have two numbers 1 to 5, and then you are giving a space of 1. So this command right here will create an array with numbers 1, 2, 3, 4, 5, and then you have asked to print those numbers, print x. So that's what this line has done. It has printed like 1, 2, 3, 4, and then you can still print x squared. So when you give this particular command, it will print the square of each number in this array. So it's 1 and 2 to the power 2, 4 to the power 9, 4 to the power 416, right? So you can see that this makes things very easy. And if you need to like access each element in this array, you just need to call it as x, which is the name of the array, and then give the index. If it is x0, it will be this number right here. If it is x2, this will be 0, 1, 2, this number right here. So those are the numbers that it has printed here. So that's the array capability of here. And I know that the one that who did this Mathematica or MATLAB, they would know that this capability is in MATLAB and Mathematica as well. The problem with those is they are actually not free, right? So you have to pay for those things. Now for this one is completely free. And there is a nice package which is called SciPy as well, which has all these scientific calculations built into that package. Once you import it, it will be much easier for you to use that. And here is a function. If you have done something about functions in other programming languages, you probably will understand this very easily. So you can define functions like my function x right here. And then this what this simple function does is it takes the value of x and then square it. So that's the task of the function. Then if you once you need to call the function, you just this is the end of the function from here, and then you print my function, and then 5 you input the function, the number 5 for the function. So it will take 5 and we'll go into here and assign number 5 for x and get the square of that and return it. So it will be 25. So that is the answer given, right? So these are just so there are a lot of things that I don't have time to like discuss all these things. So I'm just going through some of the features that you have. And there is another function. And these things are the same things you probably will be learning or you would have learned in other programming languages, but much easier here. And then there is a feature called plotting, that you can plot any type of graph here without much of a problem, right? And this can, you just need to, again, you have to import this particular library, import matplotlib pyplot as plt. So that is the name of the plotting library in Python. So that you just import it and then use it. So once again, now you have created 2 sets of like numbers for x and t here. Basically, the numbers are the first one right here. You use the numpy package and make an array of numbers from 0 to 10 with a space of 0.1, right? After that, excuse me, you get the sign of those numbers. X, P, T, S is a new variable. So what this variable gets is np.sign of these numbers. So that's why you have this particular name TPS right here. Now you have some numbers and the sign of those numbers. Sign means the trigonometric sign. And then you can do is you can have these small codes to produce a plot. So these are like standard way of making a plot. So you just write a name, call my figure, and then you ask to plot a figure. And this PLT is the package that you have imported. Import pyplot as PLT. So this is the package available in the Python, and you have shortened the name of that and leave it as PLT so that you can use this particular short name later. Right? So that is what you have done here. So you have a my figure and then PLT dot figure is the name given, and then you just follow these codes. I mean, these codes are not that much hard to understand. And then you plot, and this will be the output. Just put some numbers and have make a plot. So that's what we have done. So from 0 to 10, you have these numbers right here from 0 to 10, one by one. And then for the y-axis, for this axis, you have taken the sine value of those now 10 numbers, which give you a sine curve. And then you can, those are the basics. And if you just, once you get used to, you can like add two plots if you need in one diagram, and those kind of things. And maybe two plots in one page. So like that, you can do a lot of things. Even you can do like many plots in one diagram. These are just small changes to the code. You can do these things. So I will not go through each and everything. And this is interesting that we will probably maybe if we have time, we will be using this feature that you can solve differential equations. Right? So this is F equal ma, and then you just import these libraries. I mean, you don't need to worry this much about, just if you have time, just go through and try to like learn it yourself. So these are just generated numbers from this differential equation, and then you try to plot the graphs and those kind of things. And this is where you can get really real outputs. Now, this is important for us because once you solve this Lagrange equation, the output will be always a differential equation, right? And there are some differential equations that to look at how the solution physically looks like, you have to plot. And for these features, this particular part will be important. So that's why I need you to just go through these things initially so that you will have time when you need it. You will have time to learn about it. And there are some other options like widgets that you can use. Not sure whether these are working. Let me see. Yes, so there is something called iPy widgets, which is a package that I need to like install. Right, so that's so I will upload this to the web, and there are like I guess millions of YouTube videos and courses for Python. You can go and follow any of those courses. Keep in mind that those who like haven't done like computer science as a subject or haven't done some kind of programming, but when I talk, I realize that most of you have done some kind of programming, which should be more than enough to like learn Python yourself. And whenever needed, I will help with that as well. Right. So that will be today's lecture, and so we will meet again on next Monday. And if you have anybody have any questions up to now?